Perfect. So if we look at this particular question, we're going 34 to 37. It's looking at fossils and phylogeny and looking at the orders of that. And so when you look through this, the early Cambrian period of these trilobites were 521 million years ago. I can't even draw a line straight. Until the end of the Permian period, 250 million years ago. And so looking at this chart below, this is based on fossil evidence, and it shows the phylogeny of these trilobites across that time. So let's jump straight to the question. You can clearly see that every time something ends, that means it's been a mass extinction, and you see the diversity of events. This is obviously diverging from these particular points as well, and the different time scales. So I'm just going to go straight to the question. Trilobite fossils in a particular layer of rock were used to date a fossil shell in the same layer. A paleontologist dated the fossil shell to 328 to 359 million years old. It is most likely that these trilobite fossils present were of the order which one? So we look at this 328 to 359 million years. What actually still existed upon that? So we go back approximately here, and the only one has to be Q. It can't be Z, Y, R, T, S, and V, because those orders were discontinued due to some sort of mass extinction. So therefore, the answer is C. And people found this pretty accessible, with 78% of students getting this correct. Now we go down, and question 35 looks at the absolute age. Okay, looking at some sort of dating technique now of the trilobite fossils was most likely determined by using what type of dating. Well, if I look at back of the trilobite fossils and we look at the time period, it was a long time ago, from 251 million years ago to around that 521 million and 542. It clearly shows that carbon dating has to be ruled out, because carbon dating has a half-life of 5,730 years. So carbon dating is no. Transition fossils and index fossils will leave for a second. Coming to D is potassium-argon dating. And potassium-argon dating actually has a half-life of 1.3 billion years, which is actually a very long time when you think about it. So that looks like a way in which we can actually do so. So D is the right one. We can actually eliminate transition fossils and index fossils because we've obviously found our correct answer. So it's all about the dating periods. This is simple. Well, not really simple, but I'll say rote learning, of just knowing the amount of years and actually looking at the orders of what would be relevant and the half-lives in that way. We move to question 36, and the geological time periods shown on the chart differ in duration because the time periods, and I'm assuming that means reflect what? So the time periods actually differ on the basis that there's been extinction and there's obviously been diversity in terms of what's occurred. So if I go back to this, I look at A, it's the diversity of fossils and mass extinction events. I think the big thing is mass extinction, because obviously when that ends, that fossil has occurred there. So A would be the right one. The absence of trilobite fossils in the late Cambrian period. No, that doesn't actually make any difference to it. The different rates of radioactive decay, that's obviously not reflected in it either. We're talking at the orders of these fossils. And the different rates of fossilization actually aren't present within the chart. It obviously varied. So if you look back at this particular schematic, every time this ends, that is due to mass extinction. Then you've obviously got different timescales from when they were born as well for these trilobites. So therefore, A for this one. The chance of a trilobite becoming fossilized is increased by what? What is it actually increased by? Let's have a look. Okay, we want to increase the fossilization of this particular species. So if we're looking at that, and so that's what question 37 is sort of looking at, is the idea of fossilizing, how it actually increases that. The slow burial of its remains in dry sediment. Well, I think it's given away that this answer is incorrect by the idea of slow. If we want to increase the rate of it being fossilized, then we want to increase that rate, or we'll make it a fast burial. So get rid of A. Large temperature variations in the sediment containing its remains. We know that large fluctuations in temperature is not actually conducive to fossilizing these particular things. I don't even think that's a word. But we get rid of B. The presence of hard body parts. That looks like the right one, because if you actually have hard body parts, that is hard to actually penetrate, and therefore that will increase the rate of, or not the rate necessarily, but it'll increase the chance of it becoming fossilized. And we know that if you've got scavengers, that will actually degrade the particular remains at that time. So therefore D is not incorrect. So C is the winner.